Hello, good afternoon, or welcome back to the online classes on probability and random variables. Today, let us have a review of the last class. So, in the last class, we had some troubles while live streaming. So, I think that you might have missed some of the points. So, I'll just have a review of the and proceed with today's class. Hope you are all present. Okay. The axioms of probability. So, from the So, from the classical probability concept, we move on to the axioms of probability, where we define probabilities mathematically as the values of additive set functions. So, rather we can say that the classical probability concept was straightforward and usually based on clear-cut formulas, but here we have the probability which actually can be shown as values of additive set functions. And here we can take a simple example where the elements of the domain are sets while the elements of the range are non-negative integers. So, namely a set function is that assigns to each subset A of a finite sample space of S the number of element in A written as n of A. So, suppose we have a sample space S and we can show an element A in the sample space. Then we can assign a number to that element A which is shown as n of A. So, let us take an example here. Suppose that 500 machine parts are inspected before they are shipped. That I denotes that a machine part is improperly assembled. D denotes that it contains one or more defective components. The distribution of the 500 machine parts among the various categories is shown by a Venn diagram. Okay. So, here we are dealing with a problem. So, in the problem we have or an example, here we have 500 machine parts and they have to be inspected before they are shipped, and here I denotes the machine part which is improperly assembled. So, I denotes improperly assembled, then D denotes that it contains one or more defective components. So, here D denotes defective components. Now, the distribution of 500 machine parts among the various categories can be shown by the Venn diagram. Here we have the Venn diagram. So, there is a classification of 500 machine parts, and here we have shown certain numbers. So, here the sample space can be shown by S. So, S is the sample space. So, we can see the sample space here, and the event I, then D, then the intersection of I and D. So, here okay. So, here this is the classification of 500 machine parts. Okay. So now we can proceed further. So from this from the axiom we have discussed, that is, here the axiom says that a set function that assigns to each subset of A and in a finite sample space S as a number of elements in A can be written as n of A. Okay. So here this must be shown as additive set functions. So how we can show this as additive set functions? Let us see. So using the example, we can discuss about the property of additive set functions, and which is the important point in axioms of probability. Okay. Okay. So let us show that the numbers, there are some numbers in the figures and what that denotes. So here first one, that is in the figure n of I intersection D equal to 20. Then n of, so here actually n of I intersection D complement, n of I intersection D complement equal to 20. Then next is n of I intersection D is equal to 10. The next one, n of I complement intersection D equal to 5, and n of I complement intersection D complement is equal to 465. So these are the numbers shown in the figure or in the Venn diagram. So in the Venn diagram, as you can see here in the diagram, so this shows the number 20. The number 20. So what is this 20 actually? 20 is n of I intersection D complement. So actually already as discussed in the example, I is the number of machine parts which are improperly assembled. Okay, which are improperly assembled. So here I stands for improperly assembled, whereas D shows the machine parts that are defective. Okay. So then again, what do you mean by D complement here then? So D complement is the machine parts which is not defective, So D complement or D prime shows the components which are not defective. So the number of components which are improperly assembled as well as not defective is equal to 20. So that is indicated by the number 20 here in this diagram. So the number of components which are improperly assembled and not defective, because D stands for defective, then D complement or D prime stands for not defective. So the number is 20. Then the second value, n of I intersection D. So here I intersection D equal to 10. So let us see in the figure, n of I intersection D equal to 10. So this portion of the Venn diagram, okay, you can see the intersection of I and D, the value is 10. So what does it mean actually? It shows the number of machine parts which are improperly assembled and defective. So which are both improperly assembled and defective. Okay. So then what is the next value? Next is n of I complement intersection D, which equal to 5. So here the number of machine parts which are properly assembled. So because I stands for improperly assembled, then I complement stands for properly assembled, or we can say rather say which are not improperly assembled, which means that is properly assembled. So n of I complement intersection D is equal to 5. Okay, so this shows 5. This region shows 5. So which is the which means the number of machine parts which are properly assembled and defective. Okay. So next one is n of I complement intersection D complement is equal to 465. So here I complement stands for the machine parts which are properly assembled, then D complement stands for the machine parts which are not defective. So the number of machine parts which are properly assembled and not defective, so which are both properly assembled and not defective, is equal to 465. As you can see, the balance or the remaining portion here, the remaining portion shows 465, the value 465. So here we can find that we have several values or several subsets. Okay, we have several subsets, and these subsets mean different things. Okay, and using these values and the fact that the set function is additive, meaning that the number which it assigns to union of two subsets and which have no elements in common is the sum of the numbers assigned to individual subsets. So we can determine the value of n of a for any other subset of a of s. Here we say that the set function is actually here we can important point to note is that the set function is additive. Okay, so we have additive set functions. So this is the important point in the axiom. The set function is additive, which means that the number which it assigns to the union of two subsets and which have no elements in common is the sum of the numbers assigned to the individual subsets. So we can determine the value of n of a for any other subset of a of s. തരത്തിൽ നമുക്ക് അഡിറ്റീവ് സെറ്റ് ഫംഗ്ഷൻ ആയതുകൊണ്ട് നമുക്ക് വേറെ ഒരു സബ്സെറ്റ് ഇതിൽ നിന്നും ഈ തന്നിരിക്കുന്ന സബ്സെറ്റിൽ നിന്നും നമുക്ക് കണ്ടുപിടിക്കാനാവുന്നതാണ്. നമുക്ക് ഈ തന്നിരിക്കുന്നതൊക്കെ ഇതൊക്കെ സബ്സെറ്റുകളാണ്. n of I intersection D complement equal to 10 എന്ന് പറയുന്നത് സബ്സെറ്റ് ആണ്. ദെൻ n of I intersection D equal to 10 എന്ന് പറയുന്നത് വേറെ സബ്സെറ്റ് ആണ്. n of I intersection D എന്ന് പറയുന്നത് മറ്റൊരു സബ്സെറ്റ് ആണ്. Then n of I complement intersection D complement is equal to 465. So this actually shows the numbers. Okay, the number of, so here n stands for n, the number of I intersection D complement. So which is the number of machine parts which is improperly assembled and not defective is equal to 20. So which shows some number, and actually this subset belongs to the sample space S. ഈ സബ്സെറ്റ് എന്ന് പറയുന്നത് ഈ സാമ്പിൾ സ്പേസിലെ ഒരു സബ്സെറ്റ് ആണ്. ഓക്കെ, ദെൻ ഫ്രം ദീസ് സബ്സെറ്റ് ഓർ ദീസ് വാല്യൂസ് യൂസിങ് ദി തിയറി ഓഫ് additive set functions we can write n of I complement n of I complement is equal to n of I complement intersection D plus n of I complement intersection D complement equal to 5 plus 465 equal to 470. So let us understand from the Venn diagram. So let me save the class.
Hey everyone, I'm at the airport about to board my flight, but okay, I gotta admit, this is actually a film set for an
Okay, so let us see from the Venn diagram. We can see the value 465 and 5. Okay, this value. So actually the value 5, as we have shown here, is n of number of I complement intersection D. So which is the machine parts which are properly assembled, both properly assembled and defective. So equal to 5. So take the value 5. Then n of I complement intersection D complement, which is the number of machine parts is which are both properly assembled and not defective, is equal to 465. So 5 plus 465. So what is that? What does that show? That is equal to, so using the axiom of additive set function, or using the theory of additive set function, we can write n of I complement. N of I complement actually means the number of machine parts which are properly assembled. So the number of machine parts which are properly assembled is equal to the number of machine parts which are properly assembled and defective, and the number of machine parts which are properly assembled and not defective. Okay, so this makes some logical sense. So the number of machine parts which are properly assembled. So here, because I stands for improperly assembled, then I complement stands for properly assembled. So the number of machine parts which are properly assembled is equal to the number of machine parts which are properly assembled and both defective. So which are both properly assembled and defective. Then because D stands for defective, and the number of machine parts which are properly assembled and not defective, because D stands for defective, D complement then stands for not defective. So which is equal to the number of properly assembled machine parts. So the numbers are 5 plus 465 is equal to 470. Okay. A similar way we can find n of I union D is equal to n of I intersection D complement plus n of I intersection D plus n of I complement intersection hello ഞാൻ ക്ലാസ്സിലാണ് തിരിച്ച് വിളിക്കാം. ഓക്കെ. n of I complement intersection D. So which is equal to, so from the values given here, n of I intersection D complement equal to 20 plus n of I intersection D equal to 10 plus n of I intersection D equal to 5. So we can add these three values, that is 20 plus 10 plus 5 equal to 35. Okay. So does this make a sense? So what is actually n of I union D? So the number of machine parts which is either improperly assembled or which is defective is equal to the number of machine parts which are improperly assembled and not defective. Okay. Then plus the number of machine parts which are improperly assembled and both defective, which are improperly assembled and defective. and plus the number of machine parts which are not which are properly assembled and defective. So here this makes the set I union D, the number of elements in the set, that is n of I union D equal to 20 plus 10 plus 5 equal to 35. So how you get that? You can take the sum of these three. Okay, that is number of I intersection D. I intersection D. So I intersection D means the number of machine parts which are properly assembled and defective. Okay, so we have to take such cases which are defective. So we have to consider cases which are defective. So for that we have to take the cases which are improperly assembled, because we have the first part is I. Since the first part is I, we have to take all the cases of I. So here the cases will be first is n of I intersection D complement, then n of I intersection D, then n of I intersection I complement intersection D. So here again in the second part we have to consider D also. So considering D, we have D here in the first section, since already we have taken I. Okay, so that is there already. Then n of I intersection D. So here we have D. Okay, so considering that, we have to take n of I intersection D. Then again we have D in the third set, that is n of I intersection D. So that is n of I intersection D. So considering all the cases, because looking at the Venn diagram, we can find that the set I union D means all the elements in I, in all the elements in D, and all the elements which are present in both. Okay, so all the elements in I, all the elements of I, all the elements of D, then all the elements which are present in both. So the numbers are 10, 5 and 10, 20, 5 and 10. Okay, so therefore we can take 20, 5 and 10, so which is equal to 35. So next one, next is n of I intersection I complement union D. So which is equal to n of I intersection D plus n of I complement intersection D plus n of I complement intersection D complement. Okay, so now here we have to find the values, or we have to find the number of elements in the set n of I complement union D. So here I complement stands for properly assembled machine parts which are properly assembled. So we have to see the Venn diagram and mark the region which shows the machine parts which is properly assembled. Then second is D. The D stands for the machine parts which are defective, because in the Venn diagram straight away we can't get this number of I intersection union D. Therefore we have to add these three, because these three values are available. So already we have n of I intersection D, which is shown by 10. So take that as 10 plus, then second is n of I complement intersection D. So that is available, n of I complement intersection D equal to 5. And the third is n of I complement intersection D complement. So that is available, n of I complement intersection D complement is equal to 465. So 10 plus 5 plus 465, which is equal to 480. Okay. Okay, I think only 2 of them are watching the class. I find only 2 people. Abida Labib is there. Yes, and I don't know who else is there. Can you please comment on the live chat, because I thought that you may be present today. This particular slot was my class, and I think you have to be present in the class. Okay, so anyway, let me proceed. So here n of I complement union D, which shows the number of machine parts which are properly assembled and which is defective. Okay, so it may contain the values or the elements which are properly assembled, the number of machine parts which are properly assembled, and the number of machine parts which is defective, and the number of machine parts which are both properly assembled and defective. So again, logically this makes a sense, because here this is equal to the number of the number ni intersection D, which means that the number of machine parts which are improperly assembled and defective, because this already contains D. So we have to take all the cases, all the sets which contains the value D. Okay, so therefore we have to take this one and this one. So we have considered these cases. Then next one is n of I complement intersection D, because we have I complement here. So you take the case of I complement here, one case, the second case is this one. So we have taken n of I complement intersection D and n of I complement intersection D complement. So cases where we have D, all the cases where we have D, and all the cases where we have I complement. So totally we will have these 3 sets, that means this one, and this one, and this shows again the additive set function, because additive set function in the sense we have added 3 sets or 3 set here. So our first set here, subset here, second subset, and the third subset. We are adding these subsets to get the set, subset, another subset n of I intersection I complement union D. So which is 10 plus 5 plus 465 equal to 480. So let us see directly this from the Venn diagram. So here n of I intersection I complement union D, I complement union D. So n of I complement union D, which shows the number of machine parts which are properly assembled. So that will lie anywhere outside I. I എന്ന് പറയുന്ന ഈ റീജൻ, ഈ 20 എന്ന് പറയുന്ന കാണിച്ചിരിക്കുന്ന ഈ റീജൻ്റെ പുറത്തായിരിക്കും ഈ പറയുന്ന എന്താണ് പ്രോപ്പർലി അസംബിൾഡ് ആയിട്ടുള്ള മെഷീൻ പാർട്ട് എന്ന് പറയുന്നത്. കൂടാതെ രണ്ടാമതായിട്ട് ഡി എന്ന് പറയുന്നത് എന്താണ്? ഡി ഈസ് ദ നമ്പർ ഓഫ് മെഷീൻ പാർട്സ് വിച്ച് ഇസ് ഡിഫക്റ്റീവ്. സോ ഹിയർ ദി വാല്യൂ 5 shows the machine parts which is defective. അപ്പം അങ്ങനെ ഉണ്ടെങ്കിൽ ഈ 465 plus 5 എന്ന് പറയുന്നത് that gives you this 2, 465 plus 5, that is makes 470, plus n of I intersection D. What is this I intersection D? വീണ്ടും വെൻ ഡയഗ്രത്തിൽ നോക്കാം. I intersection D എന്ന് പറയുന്നത് ഈ പാർട്ടാണ്, that is having the value 10. So this value means, so here as in the example, in the subset we have to take number of the number of machine parts which are properly assembled and both defective. Number of machine parts which is properly assembled and both defective. Machine parts which are properly assembled means something which belongs to this 465 and the part here phi. Okay, so we may have an intersection of these two. Okay, so which actually means intersection here n of I intersection d. So machine parts which are improperly assembled and defective, so which is equal to 10. So it contains the number of I in the I complement union d contains all the values of I complement and all the values of d complements and all the values or elements which are common to both I complement and d. Okay, so all the cases we have to take, that is the cases where we have d, then the cases where we have I complement. So therefore we have to add these three subsets, so that we get 10 plus 5 plus 465 equal to 480. So 10 plus 5 plus 465. So 10 is the value of I intersection d, then 5 and d equal to 5, then I complement intersection d complement is equal to 465. So I complement and d complement which is the region outside this. Okay, outside this, so that value is 465. So n of I complement intersection d complement is equal to 465 equal to, so the total we have 480. Then next we can see another subset n of d. The number of machine parts which is defective is equal to number of machine parts which is improperly assembled and defective, n of I intersection d, plus number of machine parts n of I complement intersection d. So the number of machine parts which are properly assembled and defective. So that makes logic, because here what you have to show, you have to show the number of machine parts which are defective. So it contains these values, these two values, that is where we have d, that is n of I intersection d, which contains the machine parts which are defective, but they might be improperly assembled, but anyway the machine parts are defective. Again here the second one, n of I intersection d, which means again the machine parts which are defective, but here I complement indicates the machine parts which are properly assembled. Okay, so we may have machine parts which are improperly assembled or properly assembled, but both may contain what? Defective. Okay, both may be defective. So such a case we can take here as n of d. So the number of machine parts which is defective, that is n of d, is equal to n of I intersection d plus n of I complement intersection d. Okay, so which is equal to 10 plus 5 equal to 15. Venn diagram നമുക്ക് മനസ്സിലാക്കാം. So the number of machine parts which are defective, so directly we can see that is 5. The value here is defective here in 5 and as well as here also, this particular part. So here, which means that is 10 plus 5 equal to 15. So how we can show this? We can show this by the given sets. Already the given sets are here. These are the sets. So you can see the number of machine parts which are defective are contained these two sets. That is, in the first set here, n of I intersection d, so which contains d, then n of I complement intersection d, which contains d, and the other two sets do not contain d. They only contain d complement. So we have to consider these two subsets. So n of I intersection d and n of I complement intersection d, which is 10 plus 5 equal to 15. So we have n of I intersection d plus n of I complement intersection d. equal to 50. So now, using the concept of an additive set function, let us now explain what we mean by the probability of an event. So given a finite sample space S and an event A in S, we can define probability of an event by P of A. Okay, so probability of A, and to be a value of an additive set function that satisfies the three conditions, the following three conditions. Okay, so using the concept of an additive set function, let us now explain what we mean by probability of an event given a finite sample space S, given a finite sample space S and an event A in S, we define P of A is probability of A. So where A is an event, probability of A, which is an event, probability of an event, the probability of A to be a value of an additive set function, that satisfies the following three conditions. So axiom 1, 0 less than or equal to P of A less than or equal to 1 for each event A in S. So where A is an event and S is the sample space. Then axiom 2, P of S less P of S equal to 1. P of S equal to 1. Then axiom 3, if A and B are any mutually exclusive events in S, then P of A union B is equal to P of A plus P of B. So the third one shows the additive the concept of additive set functions, that is P of A union B is equal to P of A plus P of B. That is probability of A union B. So where actually A and B shows the probability P of A union B, or which means shows the probability of A or B or both. Okay, which is equal to probability of A plus probability of B. So which is an additive set function. Okay, so let us explain these one by one. So the first axiom here, axiom 1, 0 less than or equal to P of A less than or equal to 1 for each event of A in S. So here this states that probabilities are real numbers or interval from 0 to 1. Okay, so here probabilities are real numbers and their interval, the interval is from 0 to 1. So this is the probability of an event to occur, that is either 0 or 1. Okay, so or we can say from 0 to 1, the values between and inclusive of both 0 and 1. Then the second axiom, P of S equal to 1. So here this states that the sample space S, so where S is the sample space, the sample space S as a whole is assigned to the probability 1. Okay, and this expresses the idea of probability of a certain event. An event which must happen is equal to 1. ഇപ്പോൾ ഒരു ഇവൻ്റ് നടന്നു കഴിഞ്ഞാൽ അല്ലെങ്കിൽ നടക്കാനുള്ള സാധ്യതയുണ്ടെങ്കിൽ ആ ഇവൻ്റ് നടക്കാനുള്ള സാധ്യതയാണ് നമ്മളിവിടെ 1 കൊണ്ട് ഇൻഡിക്കേറ്റ് ചെയ്യുന്നത്. സോ ഇഫ് ആൻ ഇവൻറ്റ് ഹാസ് ടു ഒക്കർ, ഇറ്റ് ക്യാൻ ബി ഇൻഡിക്കേറ്റഡ് ബൈ the value 1. Okay, then axiom 3, here if A and B are any two mutually exclusive events in S, where S is the sample space, then P of A, that is probability of A union B, equal to probability of A plus probability of B. So the third axiom states the probability, okay, the probability functions which must be additive. Okay, so here the third axiom states the probability functions which must be additive. The additive set function ആണ് എന്നുള്ളതാണ് ഇവിടെ മൂന്നാമത്തെ ആക്സിയം പറയുന്നത്. That is P of A union B, probability of A union B equal to probability of A plus probability of B. Okay, so actually here axioms for a mathematical theory require no proof, and but if such a theory is to be applied for a physical in the physical world, you must show somehow that the axioms are realistic. Okay, ആക്സിയത്തിന് പ്രൂഫിൻ്റെ ആവശ്യമില്ല, എങ്കിലും അത് റിയലിസ്റ്റിക് ആണ് നമ്മൾ തെളിയിക്കേണ്ടി വരും. ഓക്കെ, so far we have so far as the first axiom is concerned, we are concerned with the fractions of the form S by n. So far as the first axiom is concerned, we have fractions of the form S by n, where 0 less than or equal to S less than or equal to n. Okay, ഇത് നമ്മൾ ഓൾഡ് ഫോർമുലയാണ് പ്രോബബിലിറ്റി പഠിക്കുന്ന സമയത്തുള്ള പ്രോബ്ലം. സോ there are there are n equally likely possibilities of which one must occur and S is regarded as favorable or a success, then the probability of success is given by S by n. ഇത് നമ്മൾ നേരത്തെ പഠിച്ചിട്ടുള്ള ഫോർമുലയാണ് ഈ S by n എന്ന് പറയുന്നത്. ഓക്കെ, so where S shows the success and S stands for success or it's regarded as favorable. It must occur. ഇത് ഫേവറബിൾ ആയിട്ടുള്ള ഒരു ഇവൻ്റ് ആണെന്ന് കാണിക്കാനാണ് ഇവിടെ സക്സസ് അഥവാ എസ് കൊണ്ട് നമ്മളിതിനെ ഇൻഡിക്കേറ്റ് ചെയ്തിരിക്കുന്നത്. ആൻഡ് there are n equally likely possibilities. ഫോർ എക്സാമ്പിൾ ഒരു ഡൈസ് നമ്മൾ ത്രോ ചെയ്യുന്ന സമയത്ത് അതിനകത്ത് 6 എന്നുള്ള ഡിജിറ്റ് 6 എന്നുള്ള പറയുന്ന നമ്പർ വരാനുള്ള ചാൻസസ് എത്രയാണെന്നുള്ളത് അതിൻ്റെ പ്രോബബിലിറ്റി എന്ന് പറയുന്നത് ദാറ്റ് ഈസ് 1/6 അല്ലേ. അപ്പോൾ എന്ന് പറഞ്ഞ പോലെ ഇവിടെ ഏതൊരു കേസിൽ നമുക്കിത് കൺസിഡർ ചെയ്യാം പ്രോബബിലിറ്റി എന്ന് പറയുന്നത്. ഓക്കെ, okay, and n is positive integer, n is a positive integer, cannot be negative or exceed 1. ഇവിടെ നമ്മൾ ഒന്നാമത്തെ പ്രോബബിലിറ്റി ആക്സിയത്തിൽ അതാ പറയുന്നത് 0 less than or equal to p of a less than or equal to 1. So the value is limited to 1. Then next one, to show that the second axiom is consistent with the classical probability concept and the frequency interpretation for a long series of repeated experiments. We have only to observe the fact that for the whole sample space p of s equal to n by n equal to 1. So ഇവിടെ രണ്ടാമത്തെ ആക്സിയത്തിൽ പറഞ്ഞിട്ടുള്ളത് p of s equal to 1 എന്നുള്ളതാണ്. So how you get this p of s equal to 1? ഞാനൊരു ഓൺലൈൻ ക്ലാസ്സിലാണ്, തിരിച്ചു വിളിക്കാം. ഓ ശ്രദ്ധിച്ചില്ല. എവിടെയാണ്? ഞാനായിരിക്കില്ല, ചിലപ്പോൾ മക്കളാരെങ്കിലും ആയിരിക്കും. ആ ആ ആ ആ ആ, ഓ ഓ ഓക്കെ, 2 മണിക്കാ അല്ലേ? ഞാനിത് ഈ ക്ലാസ് കഴിഞ്ഞ് ഒന്ന് കോളേജിൽ പോകേണ്ട അത്യാവശ്യ കാര്യം ഉണ്ടായിരുന്നു. ആ, ഓ, ഷുവർ ഷുവർ ഷുവർ, ക്യാരി ക്യാരി, ഗോ ഹെഡ്, ഗോ ഹെഡ്. ഓക്കെ ഓക്കെ, താങ്ക് യു. ആ, ഞാനത് ശ്രദ്ധിച്ചില്ല, പിന്നെ ഇവിടെ അറിഞ്ഞത്. ഓക്കെ ഓക്കെ, ശരി, ഓക്കെ ഓക്കെ ഓക്കെ. റൈറ്റ്, താങ്ക് യു. സോറി, ഒരു അർജൻറ്റ് കോളായിരുന്നു. സോ ഇവിടെ നമ്മൾ ആക്സിയം ടൂവിൽ പി ഓഫ് എസ് ഈക്വൽ ടു 1. ഓക്കെ, സോ പ്രോബിലിറ്റി ഓഫ് ദി സാമ്പിൾ സ്പേസ് ഈസ് ഈക്വൽ ടു 1 എന്ന് പറഞ്ഞാൽ ഇവിടെ എൻറ്റയർ വാല്യൂസ്, അതായത് ഇവിടെ നമ്മൾ എടുത്തിരിക്കുന്നത് എന്താണെന്ന്, എ എന്ന് പറയുന്ന ഇവൻറ്റ്, സേ സം ഇവൻറ്റ് എ ഇൻ എസ്. സോ ഹിയർ in such a way we can say that the entire set of events, if you take the entire set of events, we can show that by the number n. So where n shows the total number of events, okay, and by again the total number, which means n by n equal to 1. So to show that the second axiom is consistent with the classical probability concept and that frequency interpretation for a long series of repeated experiments, we have only to observe that for the whole sample space. The whole sample space എന്ന് പറയുന്നത് എൻറ്റയർ ഇവൻറ്റ്സ്, ടോട്ടൽ ഇവൻറ്റ്സ്, എല്ലാ ഇവൻറ്റ്സും കൂടെ കൺസിഡർ ചെയ്ത് കഴിഞ്ഞാൽ അതിനുള്ള പ്രോബബിലിറ്റി എന്ന് പറയുന്നത്, ഈ പ്രോബബിലിറ്റി ഓഫ് ദി സാമ്പിൾ സ്പേസ് as you can say that is n by n equal to 1. So that is the maximum value. Okay. And that can say that an event which is certain to occur, must happen 100% of the time. So now, so far as the third axiom is concerned, if P of A, probability of an event A, equal to S1 by n, and P of B equal to probability of another event B equal to S2 by n, and A and B are mutually exclusive, because we have event A and event B which are mutually exclusive. Then P of A union B equal to S1 plus S2 divided by n. So here the probability of the event A and the event B, and we are not considering here P of the probability of an event A and probability of an event B, which are mutually exclusive, contains only S1 and here S2. So because P of A is equal to S1 by N, P of B is equal to S2 by N, and here A and B are mutually exclusive, so then we can add directly these values, that is probability of A plus probability of B, as per axiom 3. So as shown in the axiom 3, probability of A union B equal to probability of A plus probability of B. So probability of A is denoted by P of A equal to S1 by N, and probability of B is denoted by S2 of N. Then probability of A union B is equal to probability of A plus probability of B, which is S1 by N plus S2 by N. Taking N as the common factor, we have S1 plus S2 by N, N as the LCM. Taking N as the LCM, we have S1 plus S2 by N. So which is equal to probability of A plus probability of B. Also if one event occurs in proportion, 0.36 or 36% of the time, another event occurs 41% of the time, and the two events are mutually exclusive, then one or the other will occur in proportion point 36 plus 0.41 equal to 0.77 or 77% of the time. Now you can do an assignment. The submission time is submission deadline date tomorrow, that is tomorrow is August 6th 8:21, time 10 AM. Question: in an experiment if an experiment has 3 possible and mutually exclusive outcomes A, B and C, check in each case whether the assignment of probabilities is permissible. That is A. P of A equal to 1 by 3 P of B equal to 1 by 3 and P of C equal to 1 by 3. Then next question, next subsection, P of A equal to 0.64, P of B equal to 0.38 and P of C equal to minus 0.02. Third subsection, P of A is equal to 0.35, P of B equal to 0.52 and P of C equal to 0.02. സോറി, അത് പോയ ജസ്റ്റ് ഒന്നുകൂടെ ഞാൻ എഴുതാം. സബ്സെക്ഷൻ എ, പി ഓഫ് എ ഈക്വൽ ടു 1/3, പി ഓഫ് ബി ഈക്വൽ ടു 1/3 and P of C equal to 1/3. Subsection B, P of A equal to 0.64, P of B equal to 0.38 and P of C equal to minus 0.02 subsection C. P of A is equal to 0.35, P of B equal to 0.52 and P of C equal to 0.26. Then fourth subsection, P of A equal to 0.57, P of B equal to 0.24 and P of C equal to 0.19. Okay, so you can complete the problem and submit it. So thanks for watching the video. We will continue in the next class.